Hello everyone, this is Mark R. Leonard back for AEtuts.com for my third video tutorial, and we're going to be doing something very similar that I did on my first video tutorial, but we're going to do it a little different way. So just to show you, this is what we will be creating. I've added the light rays and the dust coming through the light rays, in addition to adding smudges to the windows and a background sky replacement. So, what's going to be very cool about this tutorial is we're going to be using a method called 3D camera tracking. And for those of you who don't know what that is, basically what's going to happen is we're going to track the movement of the camera in 3D space, and it's going to allow us to integrate 3D elements seamlessly into our background plate. And to do so, we're going to use the Foundry's new plugin that they're coming out with over here called Camera Tracker. And they've graciously allowed me to use this for the tutorial. It's only in the beta testing process right now. They asked me to be a beta tester, so I've done some tests and I've asked if I can use it in a tutorial, and they said go for it to showcase some of the things that it can do. So let's start. I've thrown our footage in a composition right here, and it's the footage that you've all seen. We're going to put this up to full res. So now that we're going to apply the camera tracking plugin here, and when it analyzes it, it likes to do it at full resolution, so just make sure that's to full. So yeah, here's the interface of the Foundry's camera tracker. The best thing to do when you first get into this is to turn preview features on. And what that does is that's going to show us the different automated tracking points that the plugin has come up with to analyze. And if we go into our tracking dropdown over here, this is how we can change the different settings to get the best track for the shot that we're working on. Granted, this is not a very hard shot for this program to determine a track. So we're going to just leave everything as is, but I just want to talk about the basics of what some of these different things do. Okay, so number of features is a pretty obvious one. That's basically how many features it is going to look for in the frame. So if we crank this up, we're going to see more and more of these little dots pop up. Detection threshold basically is telling it if it's going to be looking for features in centralized locations or if you want it to be more spread out. So a lower detection threshold keeps your tracking markers spread out, whereas if, this isn't the best example, but if we're to crank this up, we're to see that they're centralized around these windows, and that's what it's going to be tracking. And the last one that's of major importance is feature separation. And basically, feature separation is what tells it how close the different features in the different regions, tracking regions, are to each other. So I don't think this is the best example, but if we crank this up, you can see that we have a lot of outliers and we have these different regions, but they're further away from the other places that it's decided to track. As I said though, we're just going to keep everything at default because this is a pretty simple track. So once you've determined all of your different tracks here, oh, and I just wanted to point out also very quick, if, say we have somebody walking through here, we can also apply a mask and say, hey, don't analyze this portion of the frame, because if somebody were to walk through here, that would throw off the track because it thinks that that's important data in determining the 3D camera move. 3D camera, or excuse me, match moving software is all based around parallax. So, you know, how this portion of the frame moves in relationship to this portion of the frame, which moves in relationship to the foreground, which moves in relationship to this pillar. So, you want optimal parallax, and as I said, you know, if there's something that would throw off a track, as in a person walking here, you can mask them out, and you use these different you know, source alpha, source inverted, matte luminance, and if you were to choose a matte, then your matte layer would pop up, and you could choose, you know, if you had done roto on a solid or something, and you could use it that way. But we're just going to go like this. So that's Camera Tracker in a nutshell, and so our first step here is to track features. So I'm going to go to the beginning here, and I'm going to click Track Features. And it's pretty cool. You can watch it analyze the frames, and they get, you know, these little tails behind them, and you can tell which direction they're going to make sure that everything is going correctly. We're already seeing over here that these tracks are getting obscured and they're a little sketchy, so we might have to omit those in the end, but it's pretty cool to watch all the different tracks go. And it's also a good idea to just keep an eye on them and remember some trouble sections because they could hurt you when you go to solve. Because that is going to be our next step once this is done, is we're going to go back through and say, okay, which of these tracks don't look like they're holding, or which are a little sketchy, because after we get rid of those tracks, then that's when the real computing happens, and it says, okay, let's make a camera for this track. Almost done here. Okay, we can see this one's going a little off. Once it goes through, it does a backwards track, and this is kind of a quality assurance track to make sure that everything that it had chosen before was a good idea. And the truth of it is, some scenes track better backwards, so it's just kind of double checking itself, and the backtrack is always a little faster, as you can see, because it's already done the initial pass, and this is, you know, reassurance. There we go. Cool. So now these tracks are all on here, and we can scrub through and check them out. And you know, we have all these intersecting bars over here. So I'm just gonna get rid of all of these. So I'm just gonna click and drag, select all of them. Then if you click, if you're on a Mac, if you click Apple, click, and you get these different things. You can, you know, delete tracks. You can throw in a ground plane, but for right now, we're going to delete these tracks. I'm sorry, you can't see that. Let me move this over. Let's see if we can find another one that needs deleting. Okay, there's another one. So, Apple, click, tracks, delete. You can also just select the tracks that you want to delete and click the delete key on the keyboard. That works as well. And just to show you, these different things aren't lit up yet because we haven't created a scene and solve the camera, so those aren't available yet. So the only thing that we can do is delete the tracks. That's the most important thing. So we're getting a little more weird intersecting over here, and you know, it's alright if you delete a little more than you think you need to, because we already have a lot of great tracking markers, and we have some great parallax because we have the ground plane, we have this foreground pillar, and we've got all these windows which are, you know, very contrasty, so we're gonna get a great track out of it. Let's see what else might need some deleting here. You know what, I'm just going to go ahead and get rid of these. Another thing you want to watch for is foreground and background elements intersecting, and sometimes that will create a hard edge and it's actually not correct. I don't think it came in. But for instance, the track that was down here in this lower corner, it was riding the edge of this where it intersected with this pillar, and that wasn't a correct track because it was just looking at that little intersecting point. So if that were there, we would want to delete that as well. Okay, so we're looking pretty good here. Let's just look again. Cool. Okay. So the next thing that we're going to need to do here is solve the actual camera. So click Solve Camera, Processing. So it's looking at all the tracking markers and the different parallax and how things move in relationship to each other, and it's going to create some different things for us. So solved, reference frame 0, so that's what we started on. It produced 4 keyframes to make this move happen, and the RMS projection error is 0.176 pixels. So, you know, our error rate is going to be off, could potentially be off by about 0.17 pixels, which is perfectly fine. That's great. Okay, so once this is created, the different colors just indicate different tracks that it's not sure of the quality. So, you know, this one they're like, I don't know if this is correct, and this one up there they're saying, oh well. But the green ones are ones that it's very confident that it got a good track on. Okay, cool. So the camera is solved, and down here I forgot to point this out. Before you solve your camera, you can fill in these different parameters. So if you knew the focal length or if you knew the film back, and this is a big one. If it's just a rotational move, definitely click that because that's going to help it out a lot because rotations are kind of hard for camera tracking sometimes. But this is a free camera. It's moving on the y-axis, or the x-axis rather. Yeah, so that's something that you can fill out, and or if unknown varying would be that you know that the camera is zooming, you're just not sure the focal lengths and all that. So that's something definitely to check out. And so yeah, that's all done. Now let's create our scene, and you'll see what happens when we create our scene. Alright, so what happens now is that it's created this camera, and it's created this null, and this null is our scene null. So that's how you would scale everything in the scene. And so now that we have our camera set up, we're going to want to create some more nulls in this. So, and what that's going to allow us to do is it's going to give us a reference point in three-dimensional space of where different things are, basically. So let's go to the end here. I'm going to select a bunch of points, and I am going to create nulls on all of them. So I'm going to create a null on this pillar for reference. I'm going to create a null there. I'm going to create a null there. And you'll see why I'm picking these different points in a bit. And I'm doing the corners of the windows here. And I'm just holding shift to do multiple selections here. We don't have a track over there, but that's okay. We can figure that out. Okay, so I've got all my points selected. Oh, that one. Got rid of that one. We're going to click. And we're going to do create null object. Oh, shoot. Excuse me. We are going to do create multiple null objects. There we go. Okay. So I know these are in kind of funky angles and everything, but that's okay for our purposes. It's not that big of a deal. So as you can see, these nulls are sitting in three-dimensional space here, and they are moving with the camera. So let's go to one of our custom views here. And let's just turn this off for now. Actually, here, let's go to toggle 2D, 3D. There we go. So if we look at here, this is a very cool representation of what's going on in our scene. Back here we have all of our windows, and those are our different tracking markers. And if we zoom in, this is kind of hard to see, but the pillar is this point right here. And everything is stagnant because, it's all the camera is doing is moving in the scene. Nothing in the scene is moving. It's a room. So this is a representation of the room with our different nulls and our little point cloud and how the camera moves in relationship to it. And that right there is our scene null that I was talking about. So if we're to scale this, you'll see everything kind of blow up. And basically, that's helpful for if you're exporting to a 3D program and you know that the scene is going to come in half as big as it should, and sometimes you get some weird compatibility things going on there. So that's why the scene null is there. Luckily, we don't have to deal with that. We should be fine. So let's go back. And that's, to get to here, I did the toggle 2D, 3D button. And I'm going to put this back to our active camera. Cool. Okay, so real quick, I just want to talk a little bit about 3D camera tracking and why that's important as opposed to a 2D track. Basically, a 3D camera track is very important if you are integrating 3D elements into your 2D plate. So, if this scene isn't too complex, but if you could imagine, a scene where the camera went around in a 180-degree arc, or we were moving at a diagonal or something, it would be very hard to bring in something that you created in 3D into that, because you have to make sure that your cameras line up perfectly so that you don't get any drifting of your element or anything. And a 3D camera track gives you that camera and those specified points in 3D space to say in your 3D program, hey, these things are these different places, so build your scene around this camera and around these different objects that you know are there. So and something else that I'm going to suggest, we're not going to do it in this tutorial just because it's not necessary. If we were, say we had to put a chair in the middle of this scene, I would highly recommend creating a null on the ground, or a couple, so that you can properly place your ground plane of where that chair is going to sit, because that is really important, and that's something that if you don't have a good ground plane, you're definitely going to see that when this camera starts moving around. You're going to see the chair start sliding and everything. And even as simple as when we add our smudges to the windows, if we just did a 2D track, it wouldn't stick very well because of the lens distortion and the way that the camera moves. But if we put the smudges in 3D space on this wall, then it's going to be exactly where it should be in relationship to where the camera is. Okay, great. So now we have all of our tracking markers. Everything is looking good. So next what we're going to want to do is we need to get all of these nulls out to our 3D program so that we can actually create these light rays that are going to be coming out of here in true 3D space. And because Shine, the way I did it the first time, is just a 2D plugin. It doesn't actually create them. We can't actually, dolly around these volumetric rays. And we're going to make it so that we actually can do that. And it's going to be really cool. So to export it, what we're going to be doing, we're going to be using a script, and it's called AE to Cinema 4D. And I'm going to show you guys just how to get that real quick. So I just Googled AE to C4D. Click that, and it's right here. So you're going to download the script. You're going to put the After Effects script in the After Effects script folder, and you're going to put the Cinema 4D script in the Cinema 4D script folder. So yeah, go ahead, feel free to do that. So the next thing we're going to do, I had a little bit of trouble with this when I was first doing it, so I just want to give you an easy way to export it. What you're supposed to do is you're supposed to select your nulls and your camera like so, and you're going to go to File, Scripts, AE 3D Export. Oh, excuse me, PT AE to Cinema 4D. But I had a little bit of trouble, so this is what I would recommend doing. I'm going to rename this composition first Track, the one that we're working on. Okay, I'm going to create a new composition. Let's make sure it's the same size. It's 2K, so that's 2048 by 1152. Okay, and we're going to just copy all of these nulls in this camera into this new comp, except our scene null, which is this. We don't need that. So let's just copy and paste that into here. And actually, you know what? Let's make these comps the same length. So this one is 116, and this is... Actually, I believe it's 40 frames. Pretty sure. Yep, 40 frames. Cool. Okay, so there's everything. You can see them moving away there as they should. And one more other thing you have to do. If you do export straight from this composition, you have to unparent everything. Everything is parented so that when you scale it, it all stays together. But this export script does not deal with parent layers. So when I copied it in here, it went away, but just keep an eye on that. So we're going to select all of these. We're going to go File, Scripts, AE to Cinema 4D. And it's going to prompt you for a text file. And so let's go into our camera tracker 2. And we're going to do 3D tracking data from AE. AE, there we go. Cool. And it's done its thing. And let's just pop open the Finder real quick just to make sure. And there it is. And if you want to check it out, that's what it looks like. It's giving us all the pixel values in X, Y, and Z space for each null and all that, which is pretty cool. And yeah, so I'm going to pop over to Cinema 4D and we will continue from there.